This is Daryl with Cisco Hands-On Training. Earlier this week, the FCC commissioner proposed new net neutrality rules, and I thought I would talk about QOS and the need for QOS versus net neutrality. Website ciscohandsontraining.com. I will post this presentation to the website. And I do want to mention I have some opinions today. My opinions are my own and nobody else's. I want to tell you a story about why we need QoS. Years ago, about 7-8 years ago, I was working and I had an IP phone at home off of my DSL router, which would connect back to work. And I received a phone call. And I was working on the computer, and I was incorporating my email, and it downloaded an email with a large attachment. And what happened was the DSL line has a limited amount of bandwidth, and the voice over IP traffic was coming over the DSL line, and my email download was coming over the DSL line, and the DSL line saturated. And as a result, both the email and the IP phone call lost packets. Well, the email just downloaded more slowly, and that's no big deal. Email isn't like a real-time application. But my phone call received horrible audio. I couldn't hear things. Everything just suddenly started breaking up, and that was a problem. The solution is to give the traffic that is important right now, the real-time traffic, the voice traffic, or in some cases the video traffic, priority over traffic that is not real-time, such as email traffic. I mean, whether I get my email in 10 seconds or 20 seconds, who cares? But if my voice over IP traffic is being dropped, the audio is breaking up and I can't work. So, the other interesting thing is, even if I had doubled my bandwidth on my DSL line, it would not have solved the problem. The TCP socket where the email was being downloaded would have simply transferred more data, more email, more quickly, and would have filled up the DSL line until it started losing packets, but the voice traffic would start losing packets at the same time. So prioritization is what we need. Voice traffic is real-time, and so it should have priority over non-real-time bulk traffic, and that's what QoS is for. There are different types of QoS. Latency there are different characteristics of traffic. Latency is how long it takes for the packet to get to the remote site. So if you're connecting to a data center local in your town, your latency might be a couple milliseconds. If you're connecting to a server on the other side of the planet, your latency could be hundreds of milliseconds. Jitter is the variation in the latency. So if you send 2 packets to a particular server, if one packet gets there after 10 milliseconds, and then the other packet gets there after 13 milliseconds, then you have 3 milliseconds of jitter. And then there's packet loss. Packet loss is how just simply, is just a result of limited bandwidth. You don't have enough bandwidth at some point in the path. The routers drop packets. Different applications respond differently to different types of quality problems. Some applications operate more slowly when they have high latency. Playing video games are very dependent on latency. You don't want to have 300 millisecond latency when you're playing an interactive real-time game. But voice traffic is very susceptible to packet loss. Let's talk about the different application priorities. The most important thing with QoS is to keep your network up. So the highest priority is network control, which is keeping your local area network operational. Traffic between your routers and switches. You don't want your spanning tree BPDUs to be dropped, for example. That's network control. Inter-network control is keeping your internet up. So the difference between network control, which is keeping your LAN up, that might be giving priority to OSPF. Inter-network control would be keeping BGP up. There's no sense trying to keep BGP up if you can't even keep your local area network up. Then voice traffic typically is given the next priority. Then video conferencing, because video conferencing is also real time, but it's considered a little bit less sensitive than voice because it's higher bandwidth. I mean, if you have a choice between 10 voice calls and one video conferencing call, which use the same bandwidth, generally it's better to allow the 10 voice calls to work because you're keeping more people happy for the same amount of bandwidth. Then video streaming, which is different from video conferencing because it's not real time. It's you're showing something, but it's not two-way communication. And then best effort is what's called the default traffic, when you don't really know what the application is. And then there's something worse than best effort, which is typically used for things like backups. You want to back up your system when bandwidth is available, but you don't want it to interfere with anything else. So these are the QOS priorities. And typically you want the stuff that is higher priority to have priority over lower priorities, and that gives you the best overall experience. Who cares that your email takes 10 seconds to upload? It's not real time. You're not failing to hear what the person on the other end of the phone is saying to you. But your voice over IP traffic, you need to hear that right away. You can't drop any packets in voice over IP traffic because that causes audio to kick out. I gave the examples of worse than best effort applications, backups, software update downloads, stuff that doesn't matter whether it happens right now or later. You just want to use all the available bandwidth as long as it's not needed for anything else. Let's talk about how the internet protocols support QoS. In the IP version 4 header, there is a byte called type of service, which is where the QoS priority is placed. And today that's put in a format called a differentiated services code bit, DSCP, differentiated services code point. And they have different priorities, and then they also try to indicate whether it's okay to drop, whether it's okay to drop something in that stream. And then in the IPv6 header, we also have a traffic class, which is the same thing, your quality of service priority. This type of service header has been in the IP version 4 header since it was specified in 1981 and has been included in every Internet Protocol packet since IPv4 went live in 1983. So for, 26 years? 29 years ago, they identified a need for quality of service and built it into the Internet Protocol header, and that has been in place for a quarter century. Now, different applications respond differently to congestion. TCP-based applications do something called slow start, where they start out transferring a small amount of bandwidth, bits per second, and then they gradually increase bandwidth consumption, ramping up, and then they back off when they suffer packet drops. And the goal there is if you have an internet where you have thousands of TCP streams running through, they will all start out slow, so they won't saturate the net. They will gradually increase their bandwidth consumption until the bandwidth is fully utilized, and then they will back off a little bit, so that way it does not oversaturate the net. So in effect, each TCP socket is being nice and allowing other communication to occur. UDP-based applications do not automatically get built-in congestion control mechanisms. If you are coding a UDP-based application, you would have to create your own congestion control mechanism if you wanted to do that. The reality is that most UDP-based applications do not have congestion control built in because that's fairly complex. Now, packets are, you saw the type of service field in the Internet Protocol header. Those are typically set by the applications on the end hosts. Networks need to prevent applications from marking packets with too high priority. You want your application, your voice over IP application, to mark the packets with the priority which indicates voice traffic. You don't want them to mark packets with the priority indicating network control. That's reserved for network devices. You don't want somebody to do a 100 megabyte bulk data transfer and set that inappropriately with voice priority. You want them to set it with the bulk priority. So networks can listen to what the end application says, but the network has to protect itself to prevent applications from inappropriately setting priority too high. This is one of those examples where if all application programmers cooperate and everybody does the right thing, then we'll have optimal experience for everyone, but you can't always guarantee that. Now, network engineers commonly triage network applications to fight congestion. For example, if you're setting up a large enterprise wireless network, you might decide whether to allow IPv4 multicast to occur on it, to be forwarded on that net or not. And many enterprise networks do not allow multicast to go over IPv4 multicast to go over wireless. If you have low bandwidth links, you might prevent high bandwidth video from going on those links. And as you know, some UDP-based applications use a large amount of bandwidth and they do not play nicely in congested environments because they don't back off. In those cases, you might need to prevent that application from ruining the network for everybody else. The FCC has 4 existing principles related to net neutrality. Their principles are that consumers are entitled to access the lawful internet content of their choice, and broadband providers should not interfere with that. And generally these principles are referring to broadband providers, so ISPs and so forth. The second principle is consumers are entitled to run applications and use services of their choice, subject to the needs of law enforcement. The third existing principle is that consumers are entitled to connect their choice of legal devices that do not harm the network. And the fourth existing principle is that consumers are entitled to competition among network providers, application and service providers, and content providers. Earlier this week, the FCC chairman proposed 2 new FCC principles. The first is that broadband providers cannot discriminate against particular internet content or applications. And the second is that providers of broadband internet access must be transparent about their network management practices. Now, today I want to talk about the first one. Broadband providers cannot discriminate against particular internet content or applications. Now, we know that quality of service was integrated into the Internet protocols originally determined as a requirement and proposed in 1981 and approved and implemented in 1983. So for 26 years, every IP version 4 packet has had a type of service field. And for IP version 6, they cleaned up the header and got rid of everything that was unnecessary, but you notice that one of the things they kept around was class of service. It seems to me that quality of service is discrimination against particular applications. You're saying that voice applications will have priority over data applications, and that is the best way to give optimal quality of service to everyone, particularly non-real-time bulk data transfer applications. So it seems to me that the current principle proposed here, which is attempting to forbid broadband providers from discriminating against particular internet content or applications, is diametrically opposed to quality of service, where in order for some applications to work, we need to give them quality of service and give them higher priority. And in particular, we want to give high priority to low bandwidth services, and audio is the perfect example of that. Now, why is the FCC proposing this? The fear is that internet service providers will impede some applications over others for competitive reasons. So, for example, an ISP might not want to allow competing voice services or competing or data services that compete with a particular service that the ISP itself provides. For example, they might be concerned that a cable company might not want to allow video to go over the internet because the cable company is providing video via cable. Now, I can understand that, and there's a real problem there. But forbidding all application discrimination seems to me to be overkill, and in particular seems to forbid using QOS to prefer certain categories of applications over others. I talked about that, actually I already commented. So I have to say I oppose the no application discrimination proposal as stated today. Interactive and real-time applications do need priority over bulk transfer applications, and applications which do not play nicely in congested environments need to be forced to play nicely, meaning that if an application tries to suck up all available bandwidth, that particular application needs to have its bandwidth usage limited to avoid interfering with other applications. So, again, in summary, every internet packet has had a type of service or class of service field for the past 26 years, precisely to allow prioritization between applications. It's a fundamental building block of the internet, and certain applications require a particular quality of service to function properly, and the internet protocols were designed to allow that with quality of service. So while there is a real problem to be solved, I oppose the current FCC proposed I oppose the new FCC proposed principle to prevent discrimination against particular internet content or applications. I believe that needs to be reworded to allow QOS to allow certain classes of applications to occur, to allow certain classes of applications to receive the quality of service that they need to function.